It is late 1943, and somewhere in a nondescript building in Baker Street, London, a man sits across from an intelligence officer who has just placed a peculiar motorcycle blueprint on the desk between them. The agent, a radio operator bound for occupied France, stares at the drawing with visible skepticism. This machine, he is told, will be packed into a sealed container and dropped by parachute into the French countryside where he is to land. It weighs barely 30 kilograms. It can fold nearly in half, and it is meant to be his primary means of escape if his radio station is compromised by German detection equipment. The officer leans forward and speaks with absolute conviction. It will change everything about how we fight this war from within enemy territory. The agent nods slowly, not yet understanding that this small, seemingly fragile contraption, the Welbike, would become one of the most audacious pieces of espionage equipment ever devised, and that it would represent a fundamental shift in how modern military forces might conduct clandestine operations behind enemy lines. The very concept of the Welbike emerged from a problem that had plagued the Special Operations Executive since its founding in 1940. The organization, formed in response to the Nazi occupation of continental Europe, was tasked with an almost impossible mandate: to conduct sabotage, gather intelligence, and coordinate resistance movements across occupied territory. Yet the agents dropped into France, Belgium, the Netherlands, and other conquered nations faced an immediate and devastating vulnerability. Once their parachutes touched Earth, they were stranded. Movement by foot was agonizingly slow. Bicycles were unreliable and easily stopped at German checkpoints. Requisitioning a motor car was extraordinarily dangerous. Petrol was rationed, the Gestapo watched all major roads, and any attempt to acquire a vehicle risked exposure. An agent's average lifespan in occupied France was measured in weeks. Many never made their first radio transmission before being apprehended. The fundamental problem was one of logistics and physics. How could the SOE equip its agents with rapid mobility whilst simultaneously keeping them hidden? The mathematical challenge was brutal. A man moving on foot could cover perhaps 30 kilometers in a day without drawing attention. That same man, on a standard bicycle, might manage 60. But both methods left him exposed and exhausted. He needed something faster, something that could carry him from drop zone to safe house to radio transmission site without requiring fuel to be procured locally or drawing the attention that a full-sized motorcycle would certainly invite. The standard motorcycle of the era, the BSAM-20 or similar military bikes, weighed over 200 kilograms and required careful maintenance. It consumed significant petrol. It made tremendous noise. It was utterly unsuitable for an agent operating in a climate of constant surveillance and suspicion. By 1942, engineers at Welbike Limited, a small manufacturing concern based in Maida Vale, London, had begun exploring whether a radically miniaturized motorcycle might address this need. What they created was revolutionary in its constraints: a machine that weighed just 31 kilograms, that could be folded into a parcel small enough to fit inside a canvas bag, that consumed barely 2 liters of petrol per 100 kilometers, and that, perhaps most remarkably, could be assembled and operational within moments of being extracted from its storage container. The technical specifications seemed to defy belief. The Welbike featured a Villiers 2-stroke engine of only 98 cubic centimeters displacement, producing a mere 1.5 kilowatts of power. Its wheels were diminutive, little more than 20 centimeters in diameter. The petrol tank held a mere 2 liters. Yet, when operated on a moderately flat surface, this tiny machine could achieve speeds of nearly 50 kilometers per hour and travel over 100 kilometers on a single tank of fuel. The design philosophy was ruthlessly pragmatic. Every component served a purpose. The engineer responsible for its development, a man named Cyril Pullen, had pioneered innovations that would seem almost magical to soldiers accustomed to heavier machinery. The motorcycle featured a patented chain drive system that could be quickly disengaged, allowing the rear wheel to turn freely when the machine was being transported or stored. The handlebars folded downward. The foot pegs retracted inward. The petrol tank was not welded to the frame but attached with simple clamps, allowing rapid disassembly if repair became necessary. The seat itself was a leather-covered cushion that could be removed in seconds. When fully collapsed, the Welbike became a rectangular parcel, measuring roughly 1 meter in length and 40 centimeters in width, small enough to be dropped inside what was termed a Type H container, a reinforced cylindrical canister designed for parachute delivery. If you are finding this fascinating, a quick subscribe helps more than you know. There are far too many stories like this one that remain forgotten in the margins of history, and your support means we can continue exploring them. The engine itself was a technological marvel constrained by its tiny dimensions. The Villiers unit was a proven design already used in lightweight motorcycles and industrial equipment. It operated on a mixture of petrol and castor oil, the latter serving as lubricant for the internal components. The cylinder bore was only 48 millimeters, the stroke 53 millimeters. Compression ratio was relatively modest at 6.5 to 1, necessary because the fuel available to SOE operatives might be of questionable quality and octane rating. The engine began life with the crankshaft being pressed into position and the connecting rod inserted through a perfectly aligned bore. Pistons were custom cast, light enough to minimize inertia but durable enough to withstand thousands of cycles. The combustion chamber was shaped to encourage the swirling motion of gases necessary for efficient burning in such a small space. Every tenth of a millimeter mattered. Tolerances were held to levels that would have seemed impossible without precision manufacturing equipment. The transmission system was equally innovative. Rather than employing a traditional clutch and gearbox arrangement, too complex and too heavy, the Welbike used a remarkably simple system where the driver could disengage the engine from the rear wheel using a hand-operated lever. To start moving, one would have the engine running at idle, then slowly pull a cable that allowed the drivetrain to gradually engage whilst pedaling the machine forward. Once momentum was established, the pedals could be lifted away and the driver would rely upon throttle control alone. For braking, the Welbike featured simple mechanical brake systems operating on both wheels, adequate for stopping such a lightweight machine but requiring care on steep gradients. The tires were solid rubber rather than pneumatic, eliminating the risk of puncture but making the ride remarkably uncomfortable over rough terrain. Manufacturing the Welbike presented extraordinary challenges. The component parts had to be produced to incredibly tight tolerances, yet the assembly process had to remain simple enough that non-specialist mechanics could maintain the machines in field conditions. Welbike Limited produced the machines in its Maida Vale facility, where precision jigs ensured that each engine block, each frame section, and each drivetrain component matched its specification. The manufacturing process involved roughly 40 distinct stages from raw materials to finished machine. Sheet steel was stamped and welded to form the frame. Individual tubes were bent using hydraulic presses to achieve the necessary curves. The fuel tank was hand-formed from brass sheet, then soldered at the joints and painted with multiple coats of enamel to prevent corrosion. Production records suggest that between 1943 and 1945, Welbike Limited and associated subcontractors produced somewhere in the region of 4,000 completed machines, though exact figures remain classified and estimates vary considerably. A significant proportion of these were delivered directly to the SOE for operational deployment. The operational reality of the Welbike proved far more complex than technical specifications suggested. The first agent to use a deployed Welbike was tasked with collecting intelligence in occupied France during the summer of 1943. The machine was dropped in its canvas container, and upon opening it, the agent discovered that the container's parachute landing had caused some distortion to the frame. The process of unfolding and straightening the machine consumed nearly 4 hours, during which the agent remained dangerously exposed. This first experience revealed a critical vulnerability. In the chaos of a parachute drop, containers could strike trees, rocks, or buildings, damaging the precisely assembled components within. Subsequent drops included spare parts, kits, and modified padding to reduce impact damage. Some agents reported that they never attempted to deploy their Welbike at all, finding the risks of assembly and the noise of operation in occupied territory far too dangerous. Those agents who did manage to successfully operate Welbikes in the field reported remarkable advantages in specific circumstances. A radio operator in Belgium, tasked with moving between safe houses every 3 days to avoid German direction-finding equipment, used her Welbike to cover the 15 kilometers between houses in approximately 40 minutes. Walking would have consumed 4 hours, during which she risked identification at checkpoints. The noise of the tiny motorcycle engine was sufficiently distinctive that German patrols initially dismissed it as too unusual to be a military asset. It sounded rather like a motorized bicycle or scooter, which were not uncommon in occupied Europe. One account describes how a Welbike user evaded a Wehrmacht patrol not through speed but through audacity. Startled at a checkpoint, the agent simply opened the throttle and drove directly through a roadblock, the tiny machine's compact size allowing it to navigate between parked vehicles with ease. The German soldiers, expecting motorcycles to be larger and more substantial machines, were too surprised to react immediately. By contrast, the German military apparatus had recognized the value of lightweight motorcycles but had approached the problem with far less imaginative solutions. The Germans employed the DKWR-T125, a machine of somewhat larger dimensions and greater weight than the Welbike, roughly 70 kilograms, but representing nonetheless a genuine innovation in military transportation. The RT-125 featured a larger engine, roughly 150 cubic centimeters, producing somewhat more power, and possessed superior road handling and durability. However, it could not be folded, required far greater fuel reserves, and was considerably less concealable. The British Welbike was purpose-built for clandestine operations. The DKWR-T125 was designed as a general military motorcycle that happened to be relatively light. This fundamental difference in design philosophy meant that, whilst a Wehrmacht patrol might benefit from the German machine's superior performance on open roads, the SOE operatives benefited from something more valuable: the ability to transport mobility itself behind enemy lines. The Americans, meanwhile, had developed the Cushman airborne motorcycle, a slightly larger and more powerful machine that saw limited distribution among airborne forces but never achieved the compact elegance of the Welbike's design. The actual impact of the Welbike on the course of the Second World War remains difficult to quantify with precision. Historians and military analysts have never reached firm consensus on how many agents successfully used their Welbikes operationally, how many kilometers were covered by these machines, or what specific sabotage operations or intelligence-gathering missions depended fundamentally upon the rapid mobility they provided. The psychological impact on German forces is similarly ambiguous. German security forces were aware that British agents in occupied territory possessed some form of lightweight motorized transport, but intelligence regarding the Welbike specifically appears to have been limited and fragmentary. What cannot be disputed is that the Welbike represented something entirely new in military technology. It was the first piece of operational equipment specifically engineered for a role, clandestine mobility, that had never before been seriously addressed. In this sense, the Welbike was not so much a war-winning weapon as it was a conceptual breakthrough. In the decades following the Second World War, the Welbike influenced the development of lightweight motorcycle designs around the world. Engineers and designers recognized that the constraints of producing a machine that was simultaneously lightweight, portable, and functional had been solved by the British, and the principles established in the Welbike's design were applied to civilian products. The ability to fold or collapse a motorcycle, whilst never becoming a mainstream feature of motorcycle design, emerged in several post-war military machines. The concept of the motorcycle itself as a potential element of Special Forces equipment influenced subsequent military thinking. Today, a small number of original Welbikes survive in museum collections. notably at the Imperial War Museum in London and at military museums across Britain. These machines, despite their age and the decades since their final operational use, remain extraordinarily compact and remarkably complete. Handled by those who encounter them for the first time, observers are frequently astonished at how small and light the machines actually are. It is late 1943 again, and somewhere in occupied France, a radio operator removes a cigarette from her pocket, lights it with trembling hands, and listens intently as footsteps echo through the building, where she has just finished transmitting intelligence to Baker Street. Through the window, she can see a German patrol vehicle turning slowly into the street. Her radio equipment is already packed. The canvas satchel containing her Welbike sits by the door. In moments, she will unfold that remarkable machine, will coax its tiny engine to life, and will ride away from this house knowing that the patrol has no motorcycle to match her speed. The Welbike will carry her to the next safe house, and the next transmission, and the next harrowing escape. In the grand narrative of the Second World War, the Welbike occupies only the smallest space, a footnote to footnotes in the official histories. Yet it represents something profound: the capacity of human ingenuity to create solutions to problems that had never before been imagined as solvable. It stands as evidence that the war was not simply a matter of massive industrial production and overwhelming force, but of careful engineering, clear thinking, and the recognition that sometimes the most transformative innovations are the smallest ones. The Welbike, that diminutive motorcycle folded into a canvas bag and dropped by parachute into the night, was proof that mobility could be engineered into a space the size of a soldier's pack. It was proof that even in the midst of continental occupation and total war, British ingenuity could find ways to give its agents an edge. And when that tiny engine roared to life in the darkness of occupied Europe, it carried with it something that no amount of German surveillance or security could entirely suppress: the possibility of escape, of movement, of survival. That possibility, delivered in a package no larger than a man could carry, changed how clandestine warfare could be conducted. It was, in every sense that mattered, insane. It was, in every sense that mattered, brilliant.